Have you ever wondered what makes up the fabric of reality? The answer to this profound question lies in the realm of physics. Physics is the scientific study of the natural world, from the incredibly large galaxies swirling in the cosmos to the unimaginably small particles that constitute everything we see and touch. Now, let's delve deeper into the sphere of the minuscule. Here, the laws of classical physics start to blur, and we enter the domain of quantum physics. This branch of physics grapples with phenomena that occur at the nanoscopic level, dealing with particles that are so small that they are beyond our everyday perception. Quantum physics is not just a theoretical concept. It is an essential framework that helps us comprehend the universe. It might sound like an alien concept, but in essence, it's the fundamental theory in physics that provides a description of the physical properties of nature at the scale of atoms and subatomic particles. Quantum physics is the key that unlocks the door to a world that is vastly different from what our senses perceive. It presents a reality that is not intuitive, a reality that challenges our very understanding of the universe. It's a world where particles can exist in two places at once, where they can spin in two directions simultaneously, and where observing a particle can actually change its state. This might sound like a plot from a science fiction movie, but it's not. It's the reality as described by quantum physics. And it's not just about understanding the universe, it's also about harnessing this knowledge. Quantum physics is at the heart of many technologies that we use in our daily lives, from the lasers in our DVD players to the transistors that power our computers. So brace yourselves as we dive into this fascinating quantum world, a world that's filled with strange phenomena and mind-boggling paradoxes, a world where the impossible becomes possible. In the quantum world, things can exist in multiple states simultaneously, leading to a fascinating realm of possibilities. So, what are the key components that define quantum physics? This question takes us on a journey through the fascinating world of quantum physics, a realm that defies our everyday understanding of reality. To start, we have quantum superposition, a concept that's as mind-boggling as it is fundamental to quantum physics. In the world as we know it, a thing can't be in two places at once. But in the quantum world, that's not the case. Quantum superposition allows particles to exist in multiple states simultaneously, only deciding on one when observed. Imagine if you could be both at home and at work at the same time, only deciding where you are when someone checks. That's quantum superposition for you. Next up, we have quantum entanglement, another cornerstone of quantum physics. This is the phenomenon where two or more particles become inextricably linked, no matter how far apart they are. A change in the state of one particle instantly affects the other, even if they're light years apart. This seemingly telepathic connection has puzzled scientists for decades and continues to be a hot topic of research. Lastly, there's quantum tunneling. Now this one is a real game changer. In classical physics, if you throw a ball against a wall, it won't go through it, right? But in the quantum world, there's a chance it might just tunnel through. Quantum tunneling is the concept that quantum particles can overcome barriers that seem insurmountable in the classical world. It's like walking through walls in real life. These three components, quantum superposition, quantum entanglement, and quantum tunneling, form the essence of quantum physics. They challenge our everyday understanding and introduce us to a world where the impossible becomes possible, and the improbable becomes the norm. Each of these components creates a unique framework in which quantum physics operates, challenging our everyday understanding of reality. So buckle up as we delve deeper into each of these fascinating quantum phenomena in the upcoming scenes. Imagine a particle existing in multiple states at once. Sounds bizarre, right? Welcome to the concept of quantum superposition. Now let's dive right in. Quantum superposition is a fundamental principle of quantum mechanics. It allows particles to exist in multiple states simultaneously, each with its own probability. Yes, you heard that right. A particle can be in two places at the same time, or spin in two opposite directions, or even have multiple energies at once. All these possibilities coexist until we make a measurement. To understand this better, let's take a trip to the quantum world with the famous Schrödinger's cat experiment. Picture a cat in a sealed box with a radioactive atom that has a 50-50 chance of decaying and triggering a poison that would kill the cat. According to classical physics, the cat is either dead or alive. But in the quantum realm, the cat is both alive and dead at the same time. Yes, you heard it right. It's both until someone opens the box and observes the cat. This is what quantum superposition is all about. It's the idea that until we measure or observe something, it exists in all possible states at once. The act of observing or measuring forces the particle to collapse into one state or the other. Now let's take it a step further. Think about this. If we had two boxes with two Schrodinger's cats, until observed, there could be four possible states. Both cats are alive, both cats are dead, the first cat is alive and the second one is dead, or the first cat is dead and the second one is alive. All these states coexist in superposition until an observation is made. Quantum superposition defies our everyday experience and intuition, but it's one of the key principles that make quantum mechanics so fascinating and fundamentally different from classical physics. It's a peek into a world where the impossible becomes possible, where certainty gives way to probability, and where the act of observation can shape reality. Schrodinger's cat is both alive and dead until observed, a perfect metaphor for the strange world of quantum superposition. Quantum entanglement, a phenomenon so strange that even Einstein called it spooky action at a distance. Let's dive into this fascinating concept that has puzzled and intrigued scientists for decades. Quantum entanglement is a peculiar effect where particles become intertwined in such a way that the state of one particle immediately influences the state of the other, irrespective of the distance between them. Picture this. Imagine a pair of gloves, one left and one right. If you pack them into separate boxes and send them to opposite ends of the universe, the moment you open one box and find a left glove, you instantly know the other box must contain the right glove. Now let's translate this into the quantum world. When two particles become entangled, it's as if each particle knows what the state of the other is. This happens instantly, faster than the speed of light, which contradicts Einstein's theory of relativity. Hence, the term spooky action at a distance. One might wonder, how do particles become entangled in the first place? Well, they need to interact physically. For example, a photon can decay into a pair of entangled photons. Once entangled, these particles remain connected, mirroring the behavior of the other particle. This concept is not just theoretical, it has practical applications too. Quantum entanglement forms the backbone of quantum computing and quantum cryptography, fields that are rapidly evolving and have the potential to revolutionize our technological landscape. However, quantum entanglement is still a mystery. Scientists don't fully understand how it works. In fact, it challenges our everyday perceptions of the world and the classical laws of physics. But isn't that the beauty of quantum physics? It constantly pushes the boundaries of our understanding, inviting us to explore the unknown. Quantum entanglement, a mysterious yet fundamental aspect of quantum physics, blurs the lines between space and time. Quantum tunneling, a process that allows particles to do the unthinkable, to pass through barriers. This phenomenon, which seems like something straight out of a science fiction novel, is a reality in the world of quantum physics. Picture this. You're walking into a wall. In our everyday world, you'd expect to stop, right? But in the quantum realm, there's a tiny chance you could just pass right through. That's quantum tunneling. It's like the particle takes a shortcut, tunneling through an energy barrier instead of going over it as would be expected in classical physics. This happens because particles in quantum mechanics are not only particles but also waves. And waves can spread out and sneak through barriers. It's the particle's wave nature that allows it to exist in multiple places at once. And yes, that includes being on the other side of a barrier. Quantum tunneling defies our conventional wisdom, demonstrating that in quantum physics, particles can be where they are not supposed to be. A quantum physics, a realm where reality takes on a whole new meaning. In the intriguing journey through the quantum world, we've explored the key elements that make up this intriguing branch of physics. From the superposition principle, where particles exist in multiple states simultaneously, to quantum entanglement, the phenomenon of particles being inextricably linked regardless of distance. We've delved into quantum tunneling, a phenomenon that defies conventional understanding, as particles can appear on the other side of a barrier, seemingly without crossing it. These compelling components of quantum physics demonstrate that at the tiniest scales, our universe behaves in ways that are vastly different from what we see in our everyday lives. But the quantum world is not just about strange phenomena. It's also about the potential to harness these unusual properties for advancements in technology, from quantum computing to secure communications. Quantum physics, a fascinating field that continues to challenge our understanding of the universe, one quantum particle at a time.